Alright guys, today we are going like this. I don't have time to fix the camera right now. Is the quality higher this way? Is it? Is it? Is it higher? Is the quality camera higher this way? Why don't I know that? And so we will keep the Cascade model, and then we wanna user type A, user type B, and I want I wanna na 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 projects. Where are you? Projects. Where are my projects? Yeah. Where are the projects? Where do you keep the projects? View plans. What is view plans? No, fuck. Where's the fucking? Oh, ranking algorithms. Yeah. But where are the files? Ranking algorithm. Oh, okay. It's not there. Where are the projects? Wait, what happened to the projects? We don't have projects anymore? Pro is $200 per month. And Plus is just $20. the plus button. Top right of the page. What top right? Yeah, projects are here, but they're not over here. That's fucked up. Oh, okay. Fuck. It was just a matter of reload. All right, let's go to ranking algorithm. Optimal double robots or LTR. What was the question? Let's ask what is what does learnability model mean?
In machine learning and computational learning theory, a model's learnability refers to how well it can be trained to approximate or correctly classify data under certain conditions.
Fuck off!
More formally, it's the ability of a learning algorithm to reliably produce an accurate function or rule, a hypothesis, given training examples. Key factors that influence learnability.
So, wait. In machine learning and computational learning theory, a model's learnability refers to how well it can be trained to approximate or correctly classify data under certain conditions. More formally, it's the ability of a learning algorithm to reliably produce an accurate function or rule, a hypothesis, given training examples. Key factors that influence learnability include model capacity, the range of functions or concepts the model can represent, linear versus highly nonlinear functions, uh, available data, the amount and quality of labeled examples that the model can use for training, complexity constraints, the computation, generalization, the extent to which sense such as in probability approximately correct. Probably approximately correct learning, a model is considered learnable if there is an algorithm that with high probability finds a hypothesis close to the true underlying function using a reasonable polynomial amount of data and computation. Alright, so if we assume what do we want to the cascade model, cascade click model how is it learnable? Why are we doing O1 by the way? model can be ChatGPT 4.0.1 mini, more models. O1 has a deciphering, understanding learnability, and piercing together the concept of learnability in a machine learning. It's here that I noticed the definition taking shape likely grounded in formal learning theory and PAC. Understanding learnability and refining my understanding learning elements and systematic function from data, high accuracy and integrating insight. Emerging machine learning generalization with formal learning theory and alright, then it just tells you what are the steps it's taking to do its reasoning, and the answer will be under the cascade click model. A user inspects search results sequentially from top to bottom and stops as soon as they find and click on a relevant item. Stops, alright, we don't want to have the stops. From a learning perspective, this behavior imposes a relatively simple structure relatively simple structure on the data once the user relatively simple structure on the data once the user clicks the result at position K. You know that all positions below K, I mean less than K, were not above K in a sense, relevant for that query. Otherwise, well, I'm not agreeing with this part. We say that every object has a probability of relatability, and that's what makes it interesting. Yeah, it's not like, oh, okay. So, and you also know that the item at position K was relevant. In effect, each query session yields a partial but highly structured labeling of documents as relevant or not. Relatively, and relevant. This model is learnable because parameterization is simple. Typically, each document or document query pair is assigned a single relevance parameter. What are we learning, by the way? The probability that it's relevant for the query. So it is also probable. The cascade model then says a user clicks an item if and only if they reach it, and the item is relevant. Because the parameters are relatively sorted, few, and who said they're few, and enter the model in a straightforward way, it is tractable to fit them from observed clicks. Identifiability. Okay, we just don't want a learnable model. Okay, if the model is learnable, it's great. But if the problem we are dealing with is simple, then okay, then it's good. It's solved. But we want to deal with a problem for a PhD, for a paper, for a project that needs some time. It's like a considerable problem. Not if it is an easy fix, just do it. Why are you wasting my time on it? You know. Not every problem becomes a paper. Some problems are easy and they just need to be. Should not mention them. People have problems being easy. What the fuck? The cascade model then says a user clicks as an item, I'm gonna reach it, and The item is relevant because the parameters are relatively few. Okay, I read this one. Identifiability from partial feedback. Ah, that's nice. Despite having only stop start click feedback, the sequential stopping rule gives a strong constraint on which items can be relevant. If a user's if a user clicks the items at rank K, then items at rank 1 to K minus 1 are inferred to be non-relevant for that query. Well, that sucks. That's bullshit. Okay. That's your method. Alright, if the user never, okay, can make sense actually. If we have a model and we have data, we just know the clicks and position. So above that position are observed but not clicked, so we can assume they are not relevant. Non-relevant. If the user never clicks any result, then all results will have to be non-relevant. Maximum likelihood. EM-based estimation. In practice, the parameters can be learned by formulating a likelihood for observed click patterns and either directly maximize it or applying an EM procedure with sufficient click data across queries and by interleaving though still a simplification, many users do scan top results first and often stop after finding a satisfactory result, making the cascade model's assumption reasonably accurate for many ranking tasks because observed click strongly hint at which results the other. Alright. Learning product ranking robust to fake users. That's the one that I wanna. Explain the paper learning uh, user behavior follows. So in this paper, they had fake clickers and fake users, and we had this real users. And the normal users use Cascade. They wanted to find what was relevant for them, understand it. Here we have two types of users, which are from different categories. So it's not that one of them is fake and artificially trying to increase the value of their own product just because the query is broad. It can relate to two kinds of items that are not actually comparable, but because we turn everything to numbers, we are comparing them. So now we wanna do that and find categories. And then I wanna say it is kind of similar. We have two users with different intents, but they're both users and they are both important. The difference is it is different for the platform now. In the fake user example, platform wants to remove the effect of fake users, but in broad query different category example, platform wants to value both of their users, but needs to make sure, needs to find the categories. Actually, that's it. Needs to find categories, and then they can use categorization to better serve their users. User examines product from top to bottom. Click probability item I is UI. Is it probability user leaves or they don't find a suitable item? QJ. Learned of optimal ranking despite fake user interface. The colors of Y standard algorithm fails. Waiver provide that UCB-based algorithms suffer linear regret. Fake user attack can be permanently misled into placing low-quality products at the top. Keysight manipulation in early round is permanent. Permanent fake users click on low quality products, increasing their underestimate. The platform learns incorrect ranking and continues showing manipulate. Oh, if in early rounds manipulations is permanent, that sucks. Like UCB gets locked on it. Preventing recovery. What is wrong with why? Why is linear regret so bad? Why is linear regret? Dice at the top, execute, increasing their estimate, the platform. Sure, stop seeing better products, preventing recovery. Robust. Donuts. Learning algorithms. The paper introduces two algorithms to handle fake user manipulation. Fake aware ranking algorithm, which knows how many of them, knows the number of fake users F, find confidence into the concept. Product ordering graph. So their model is kind of pairwise ranking. Actually, it's good to get into their algorithms because it can be helpful for us as well. Uses multi-level ranking, works fake oblivious, works when the platform does not know the number of fake users, maintains multiple ranking hypotheses with different level of correctiveness, cross-learning between levels to filter out fake user influence. It's kind of funny. FORC significantly fake oblivious. The other one that knows F. So you have less assumption in your model. It outperforms. Isn't it crazy? It was actually in the one of the presentation we watched together by OpenAI guy. So at the beginning, when your compute is low, adding assumption helps you build something. But over the time, your computation power is high. You just want to have less assumption and more data and come up with a better. Regret measures how much the platform loses by not following the optimal ranking strategy. A ranking of linear means the platform's loss grows proportional to time, which is catastrophic in an online setting. Why? One definition of regret. Regretted time T is the difference between time optimal reward minus observed reward, where optimal reward so that is the best ranking. Why is linear regret problematic or catastrophic? The problem never recovers from early mistakes. Early development locks in suboptimal ranking. Even after thousands of rounds, the platform still shows bad product. Actual and optimal time. User experience in a sublinear regret like this, the platform gradually fixes mistake. In linear regret, persists indefinitely, leads to poor. Linear regret implies no learning. A good algorithm should improve over time. If regret grows linearly, never adapts. A good algorithm should improve over time. If regret grows linearly and never adapts, this is equivalent to random guessing forever. So we are doing actually nothing randomly. How avoid linear? That was a good reasoning. If it's known. Perfect. Okay, now I have better understanding. Let's go to the paper. Craswell et al. Please give me a complete description of cascade Sal and by what's the guy? Chris. Dude, it's so difficult bringing old people together. Ah! Guys, I'm emailing Ihsan. I'm not wasting my time here. All right, that's it. I just quit. You cannot bring three people together. It's so difficult. Invite was not sent or something like that, and the calendar was. Everybody's so busy. That's the point. The only person who is not super busy. Actually, I am being TA. I am busy too. Like the last 2 days, it took me like 4 hours, more than 4 hours, just talking to students. Even though like I have 16 students, each one 15 minutes, so it should be in total 4 hours. But I don't know why it took. Honestly, it took 4 hours. And 1 hour recitation. Tomorrow again, 2 hours. So it's fine. It's just I think one other way is just writing it down and sharing it with everybody. I like to present and we have a conversation over the model, but it's bad because okay. Oh, okay. Now we wanted to go over the cascade model. There are 2000. From now on, I will send the invites myself. That's the best thing to do. Send the invite to Munzer, send the invite to Flavia, send the invite to Ehsan, because they are all super busy people, and somebody will be missed. So we know that we will have a meeting regardless. I mean, at the beginning of semester, I sent all this like a schedule for the semester for the February. to Hassan, but I think because he didn't have it on his calendar, it's gone. In their 2008 paper, an experimental comparison of click position bias models, Crasswell et al., introduced the cascade model explaining user behavior and position biases in search engine result pages. Was it deposits that users, what the disposition, what does disposition mean? I will send the invites myself from now on. Disposition. I want to see people. I should send invite. Why should I ask Flavia? Person's inherent quality of mind and character. Person's disposition. Person's inherent quality of mind and character. Sunny disposition has a way of rubbing off on those around you. Temperament, character, temper, kidney, the way in which something is placed or arranged, especially in relation to the plan, need to be accurate so long as it shows the disposition of the rooms. So I should send the invites. I will send the invites for Negin as well. Oh, that's the best thing actually. What was that app that Sam used to do? Calendly. Sign up for free, yeah. Sequential examination, there's an experimental comparison. Crasswell et al. Introduced the cascade model to explain user behavior and position bias in search engine result page. Posits. What is posits? Is this position? Positive. Posit is assume. This guy always knocks on the window. Assumes as a fact, put forward as a basis of argument. Oh, posit means assume as a fact, put forward as a basis. Assumes. Posit means assumes then. Confusion, view posits, a perfectible human nature. Postulate, put forward. Advance, propound, submit, predicate. Presuppose, presume, assume, put in position, place. Posit and deposit. Disposition is no related. All right. Where was posit? That users scan search results sequentially from the top, deciding that I know sequential examination. Users view search result from the first position downward, assessing each result one at a time. Immediate click decision. Upon examining a result, the user decides whether it's relevant and clicks on it with a probability specific to the user, to the result. Well, so this part of our model and Negin's model will be different because I wanna, for the purpose of learnability, I wanna let my users click on multiple objects. And I think it makes sense because we are facing a broad query, and on the broad query phase, like we can say consideration set behavior. Yeah, immediate click decision. Upon examining a result, the user decides whether it's relevant and clicks on it with a probability specific to that result. Termination, upon click. If a user clicks on a result, they typically do not continue to subsequent results, effectively ending their search session. Termination, upon click. Clicks on a result. If a user clicks on a result, sounds good. You're a user, you're clicking on some result. They typically do not continue to subsequent result. Well, I want to let it to continue. Ending their sessions and no skipping. Users do not skip. Implication of the cascade model. Position bias. We don't say position. 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 Higher ranked results have a greater chance of being seen and click probability dependency. The likelihood result being clicked depends on both its position. Oh, actually interesting. Creswell et al. Conducted experiments by deliberately altering the ranking position of search results to observe changes in click behavior. Their finding indicates that the cascade model more accurately reflects user behavior to other models, such as those assuming a uniform decay in attention with lower ranks. The study concluded that users are more likely to click on higher rank results due to their position, underscoring the search engine rankings. Standing user interaction with give me mathematical writing of the model. I want to let the users be able to click on multiple choices. So once they click on one item, they may still not explore, examine remaining items as well, next items as well. If they click, they exit. Even if they don't click, they exit. Fuck this. I don't like this one. Actually. Relevance and observe. I don't like this model actually. Exit. Exactly. One instead of 1 minus qi c pi I, we should say what is the probability of going from position I to I plus 1. This one says this. Position J does not continue is, what if you just does not click but also, yeah. So here it assumes that with probability 1, if you don't click, you will go to the other problem. True rate is single click probability. That doesn't make sense. This model doesn't make sense because it says they will go check all the way down. No, they can even revise model. Okay, I want to let the user be able to exit even if they do not click at position J. So QJ So in my sense, in some sense, my model is simpler. I'm just saying that they go or keep going. So instead of, okay, we can add those addition. Yep, I like that. I wanted to keep it simple. Okay, here is it assumed that once we have QJ of click and with QJ of non-click, which is more complicated to be honest. I mean it makes sense, but I don't care. There is a of item over J position, the examination. Then we don't have lambda j. Why should we have lambda j? Lambda 1 is 1, lambda 2 is 1 minus q1. I mean, there is no lambda. Fuck lambda. I mean, effect of lambda, like the position bias, is already considered in those quit probabilities. That's so wrong, actually. Lambda j should be 1, in my opinion. Okay, in my model. Fuck you and your model. Alright. In my model, for simplicity, yeah, I want to start my model simple. Let's have qj of click equals qj of no click equals qj, and the effect of position bias is modeled through exit probability of the user. So lambda j is unnecessary, and we can assume for each j. No explicit position bias. Exactly. That's a good articulation. So position bias is implied through the exit strategy. Users with exit with probability qj, regardless of whether they clicked or not. No explicit position bias. Lambda j equals user always examine the next positions unless they exit. Yeah. Now my question is, why Crasswell assumed that? All right. Alright, pi j, the item position j, mu pi j intrinsic, click probability j, exit probability at position j, c pi j. Well, if it's click otherwise 0, RG probability of reaching position j, user behavior, probability mu pi j exists, equal to the qj independent of clicking, continues to j plus 1 with probability 1 is qj. I see. Reaching position j base case, the user starts at position r1 is 1. What was r? I don't want to say r. Instead of r, let's use o. Instead of r for examination, let's use o, as r is better to stand for relevance. Or me. So I also have another question, which is a side note, that why do we assume an explicit positional bias in the Creswell model, cascade model? J probability that user reaches position J, by J intrinsic click probability. And so one other thing I wanted to use is I mean, that's a more general model, so you can always say that it has more room to model the true real world, but it's more complicated. So I don't know, maybe we need to add that, but yeah, that's true. That model, but I want to keep it as simple as possible. Position bias model is qj equals 0 exactly. Click probability on intrinsic attractiveness. Exponential user patience modeling. That's very nice. I like that. Now we want to say the other one thing is that, okay, give me like, uh, then we want to go explicit versus implicit. What does complicit mean? Helping in doing something. Comply. Here is the. Why do we have explicit position bias in the original cascade instead of modeling it implicitly through exit probabilities? Alright, now I want to just copy my code. The original does not have explicit position bias lines through exit probability. The original cascade modeling whether to account for in the original cascade model, the probability of clicking on an item is lambda. So it means that you can arrive at position J, but you may not examine it. So it says position bias lambda J is explicitly needed to model users' attention at each rank J. Here I am saying extrinsic. Which one is intrinsic? I'm saying the attention at rank J is intrinsic or extrinsic. It's intrinsic, can be computed through QJs, but they're saying here it's not completely intrinsic. It also, we get to position J, but even at position J we have an lambda J that is waiting for us, I guess. I'm saying if you are at position J, you will examine it. They say no. Alright. Okay, there are good assumptions behind it, but I don't think it's super important. Um, main. Cascade. No categories. Section. Main. Where is main? Where is categories? What? What? Main. Oh, don't fucking use document class. Shit. N items. Like small big N. Alright, special cases, I don't want this section. Where's the reference? Alright, now we have the section. I want to say categories. greater than t. What else do I want to say? Motherfucker. Give me a second. Boston, October 17th. I don't like theaters. Yeah.
Imagine being so good at table tennis that people start calling you a cheater. This guy never touched the ball at first and pump faked the shot, clearly winning a crucial point in the game.
We have to see this again. It's just playing.
Imagine being so good at table tennis that people start calling you a cheater. This guy never touched the ball at first and pump faked the shot, clearly winning a crucial point in the game.
We have to see this again. It's just playing.
Imagine being so good at table tennis that people This guy never touched the ball at first and pump faked the shot, clearly winning a foul.
Wait, what did I watch? Alright, I totally forgot you guys. Anyways, I don't think I said anything important. ChatGPT is the key. Really helps me writing. Alright, I think I'm good. I'm gonna say goodbye to you now. It's been a minute.